let's look at part C of this question. Show that light from a sodium lamp cannot cause photo emission of electrons of sodium metal. And yeah, we can see that this question C has also two parts, right? This is part one, this is part two. So we have give like two answers to this corresponding two questions. Now we're still talking about this question here. Yeah, we are given this condition, low pressure sodium lamp thing. I'm going to give you some time to read the question. You can pause the video. All right, let's get to it. Show that light from a sodium lamp cannot cause photo emission of electrons from sodium metal. Now we want to put in some words here. Now, for the photo emission to happen, or maybe to make the photoelectric effect to take place, we have to make sure that this is greater than 0, right? It means that whatever now this is ammeter. Okay, so this is a sodium lamp. Let's say that this is a sodium lamp. Okay, and it shines this a photon on this emitter plate. All right, and to cause this like electron flow, so that this is a closed circuit, so there is current to flow. All right, so to make sure that happens, we have to make sure that the HF minus this phi. The phi is the work function of the metal. Yes, the work function of the metal. It has the property of the metal itself. Yeah, so this metal is like actually the sodium metal. So it means that the photon of light, the photon energy, has to overcome the work function. The work function is considered as, we covered this, right? The resistance energy of a metal to knock out electrons from it. So we have to make sure this happens. Yes? Now, we're given some numbers here, right? We can calculate if this HF minus phi is greater than 0. Now, if it is greater than 0, then yes, we can see the photo emission, photoelectric effect to happen. But if it is equal to 0 or less than 0, then we can't see the photo emission. And in this case, for this question, show that from cannot. See, the question is cannot. You see it, right? So we want to demonstrate that. We want to demonstrate that this is not greater than 0, and probably it should be like less than 0. Now let's calculate it. Now, so if I were to write, like put in the words, so we write something like this. Let me change the color. Here, let's use maybe orange. Yeah. Okay. So for 1, show that light. Okay. So the sodium lamp light. To make sure photo emission to take place HF is greater than phi. Yeah. Now for this question, we are given the frequency of the light, and we are given the work function of the metal. So we can use our calculator to calculate this. It's going to be 6 times 10 to the power of now remember, h is your Planck's constant. It's a constant times f. F is something we calculated from part A. Oh man, I already erased it. Let's check my calculator. Okay, let's see. Okay, it's still here, right? 3 points. No, this is not that. Wait, what is the frequency of it? Oh, here. Okay, 5.50 times 10 to the. Okay, let's do it here. 5 times 5.50 times 10 to the power of 14. It is going to be equal to. Let's use our calculator again. 6.6. Okay. Come on, calculator. 6 6.63 times 10 to the power of negative 34 and times 5.50 times 10 to the power of positive 14, if I remember it right. The answer is, okay, so 3.67 of 3.67 times 10 to the power of negative 19 joules, and or phi is given too, right? Phi is given here, right? 2.2080 evolts. So it is going to be 228 evolts. It is going to be equal to how many joules? We can calculate it. Now this constant is how we convert the evolts into joules, right? So let's do some calculation on calculator 2, 3.28. 2.28 times 1.6 times 10 to the power of negative 19. Okay, so it is going to be, so as you can see here, this work function is greater than this the photon energy, right? Yeah, because it is going to be like 3.65. This is going to be 3. Yeah, maybe I think they're similar to each other, right? Yeah, pretty close, but you still can see that this work function down here is greater than the number up here. So it's going to be maybe let's let's correct this into 3 decimal places. It is going to be 3.647. Okay, maybe I wrote it wrong, a little bit wrong. Okay, should be 647, and this one is going to be 3.648 times 10 to the power of negative 19 joules. So we have HF is less than this phi, so we can't see the photo emission. Okay, so this is, if I were to put words in here, I would write something like this. And then it asks us about, by considering the energy transitions involved in light production and absorption, suggests a possible reason for this. I think this part, question B, part B, part 2, is about the Bose atom model. So I think by the end of that chapter, by the end of that unit, you should be able to explain this. But okay, we'll do a quick explanation here. So actually, what we have is so now we have the sodium light, right? It can shoot out like the photons. Why can it do that? Why can it do that? Because the sodium atoms in that, actually the electrons of the sodium in that can jump from the higher energy level. We think this is higher energy level, into this down here. So the electrons from a higher energy level jump to, actually it should be fell down to this lower energy level, and it can release some energy, and this energy is your photon energy, so that we can see photon coming out of this light. Now, since we now know that the result is that a sodium lamp cannot cause photo emission, it means that the difference between energy levels cannot overcome the work function either. The work function of sodium lamp, sodium metal. So I think this question is quite an interesting one, right? Because we are shining, we're shining the gas, not the gas, the photon from sodium lamp onto a sodium metal here. Now this metal is made of Na to sodium 2. But it cannot cause the photo emission to happen. Okay, so this is how we do this question. It has two parts, and after maybe the photoelectric effect unit, you are comfortable with these orange words. You have to know that. You have to be comfortable, like write these out.